Hi everyone, today we're going to look at graphing quadratic functions. Now the quadratic function can be written in three different ways: standard form, vertex form, and factored form. And we're going to look at each of those forms. So starting with standard form, the C value tells you a lot. It tells you the y-intercept of the graph. Yay! We definitely need to plot that when we're graphing, so it's very important. The vertex form tells you the vertex, naturally, that's why it's called that. So the vertex itself is located at HK. So if you know the H value and you know the K value, then you're set. And you know at least the vertex of that graph. Keep in mind that if it's in the parentheses, the sign is going to be the opposite. Okay, so you may even want to write that on there, opposite sign. Okay, when you write your vertex. And then the factored form, notice it's factored with two parentheses, that in this particular form, it gives you the roots. And don't forget, roots really mean x-intercepts. Okay, so R1 and R2 there are your roots or your x-intercepts. Okay, and they are also opposite signs. So I would make a note of that, opposite signs. So we're going to look back to this when we are graphing them in just a moment. So what does the A value tell us? Please note, guys, that they all have an A value. Every single form has an A value, and that tells us how skinny or wide our parabola is, but we're not going to get into that now. But it also tells us whether the graph opens up or down, which does help us. If the A value is greater than 0, that means that it's positive, right? Anything bigger than 0 is positive numbers. That means the parabola opens up. And I'm going to draw a little picture of what a parabola that opens up looks like. And if A is less than 0, that means that the number is negative, the A value is negative, then the parabola opens down. I'm going to draw a little picture of that too. Notice that the arrows go down as well, right? So let's start off by graphing a simple one, which is the standard form. Okay, the C value, remember, as it says on the left, the C value is your y-intercept. Okay, so we know at least 1 point already. Okay, we know at least 1 point. The y-intercept is -5. And we can go ahead and plot that at -5. But we need a lot more points to draw a parabola, at least 3 to 5 points. I recommend 5, and one of them needs to be the vertex. Okay, so how do we get anything else? We also know that it opens up because the A value is positive, right? So that means it opens up. Now I'm going to show you a way to get a point by hand, and then I'll also show you how to get points on a calculator. Okay, so let's see. We've got, if I want to know what happens at +1, if we want to know what happens when the x value is +1, then all we have to do is plug in a point anywhere there's an x in the equation. So x squared plus 4x minus 5. Anywhere there is an x, I put parentheses. So in those parentheses, I'm going to plug in 1, because that's my x value, right? I'm going to plug in 1 wherever there's an x. So 1 squared is 1. 4 times 1 is 4, and then that -5 is still there. So what do we get? 1 plus 4 is 5. 5 minus 5 is 0. Oh, interesting. So when I plug in a 1, my output is 0. That means that it's one of my x-intercepts. So I'm going to go and plot that point, 1, 0. And I can plot lots of different points. Okay, I can do this over and over and over and just plug in 2, plug in -1, plug in any value I want and get a point. But you can also graph it in both calculators. I'm going to show you what that would look like. We would use this math keyboard in our Desmos calculator, which you can find in the Google Classroom. Y equals x. Here's the squared button. Notice that it was a line, but now when I add the squared to it, it makes it a parabola. And then finish the equation plus for x, make sure not to use times, make sure you're using the x, and then minus 5. There's our parabola. To make this keyboard go away, just hit the arrow, and I can get a lot of other points. Here's my other root. My first root was here, my second root is here at negative 5, 0, so I can plot that as well. I already have my y-intercept. Oh, here's my vertex. Notice how when I click on this, guys, it gives me a lot of points. It gives me my roots, it gives me my y-intercept, it gives me my vertex. And if I have a point here on the left, my y-intercept, I should have an identical point here on the right. Sorry, left side. So let's go ahead and plot those points that we know. One of the other root was at negative 5. Remember, root means x-intercept. It also gave us the vertex at negative 2, negative 9. And if I want the symmetrical point of my y-intercept, all I need to do is draw my axis of symmetry. And since this point is 2 units away, then I need to draw one that is 2 units away on the other side. And so I have a point here at negative 4, 5. And now I can actually draw my parabola. There it is. Beautiful. Technology is wonderful. On the next example, I'm going to show you how to use the Inspire calculator instead. So you can use both. There are pros and cons to both. So let's go ahead and look at the next example. So looking at factored form, which is example 2, we said that the factored form tells us our roots, otherwise known as x-intercepts, and they should be the opposite signs. So since this is an x minus 5, my root is actually positive 5. And my plus 2 means that my root is a negative 2. Opposite signs, opposite, opposite, opposite. And it opens down because our a value is a negative 1 here in the front. So I can at least plot 2 points straight out of the gate at positive 5 and negative 2. Now to get other points, that's where the calculator comes in handy. I'm going to go ahead and open up the Inspire calculator for us to look at. So when I'm on the screen, the best thing you can really do is go to New to create a new file, so you don't have to worry about saving things. So here, I'm going to add a graph. Notice f of x equals or y equals is already there, so I'm going to go ahead and type in the equation myself. The equation is negative, not minus, negative, parentheses, x minus 5, close parentheses, open parentheses, x plus 2. Hit enter. You can see the graph, but the most important thing really for you is the table. Control T. We have used Control T a fair amount, guys, so we should know how to do it by now. Let's make sure that we have points that we can actually plot on our graph. So I'm going to go this way down so I can see some of our other values. We can see our x-intercept here at 5, 0. And our other x-intercept was here at negative 2, 0. And interestingly enough, these points 1, 12 and 2, 12 may not fit on our graph, but we'll probably be able to fit a few other things. So let's try 0, 10 is our y-intercept. We're going to plot that. 0, 10. And what is the point on the other side, the matching point? 0, 10. The other point would be down here at 3, 10. Okay, so I can plot that as well at 3, 10. Interestingly, our graph, we can actually plot the vertex because our vertex, you can see, would be somewhere between 1, 12 and 2, 12 because see, they converge to this spot, 6, 10, 12. 6, 10, 12. So the vertex is between these two 12s. It's actually at 1.5 something, okay? So I'm not actually going to plot the vertex on this one. I know that it does go up there somewhere and comes back down. Normally we would plot the vertex if we would have it. And the STAR test will never give you a function where the vertex is invisible, okay? Last example, let's look at vertex form here. Now in vertex form, remember those points, those numbers, 5 and 6 are our vertex. But if it's inside parentheses like this one is, it's the opposite sign. So the opposite of -5 is +5. And the -6 stays a -6. Okay? So that is our vertex, and we can go ahead and plot it at 5, -6. Now to graph the rest of it, we are going to need to go to our calculator, and I'm going to do the same thing. I'm going to use one of our 2 calculators to get more points. I'm going to use the Inspire this time. So let's go ahead and type in our equation. And remember, it's very important where you put certain things. So 2 parentheses x minus 5, close the parentheses, and then hit the squared button. And then -6. Make sure it's not a -6 that you use the minus button. The minus button is right next to the plus button. Hit enter, and there's our graph. Remember, we already have the vertex. We just need some other points. So let's go to Control T to look at the table. Oh, we've got some good points. We know that here's our vertex at 5, -6, and you can see we have points on either side of it at 4, -4, and 6, -4, 3, 2, and 7, 2. I highly encourage you to write these down. So all I really did from here, guys, was I wrote down the table that I got from my calculator, and I plotted those points to create this beautiful parabola. Notice that the x-intercepts are not whole numbers. That happens sometimes. Our vertex is a whole number at 5, -6, but everything else, and I don't know what my y-intercept is. I know it has a y-intercept. I could find it on my graphing calculator, but right now I do not know what the y-intercept is. I could pull it up. Here we go. I'm just going to go up until x is 0. My y-intercept is at 44. Well, I did not have room to graph that, but it does have a y-intercept. Please keep that in mind, that they do have them, just even though we can't see them. The last 2 things we're going to look at is some star questions, and we should be able to get these without a calculator for the most part, okay? So looking at that first one, we have it in factored form. So remember, from factored form, we can find the roots, and roots are the opposite signs. So if it's +1, our root is at -1, 0. And if it's -3, then our root is at +3, 0. Well, let's see if we can eliminate some of these answer choices then, shall we? I can eliminate, let's see, it's -1 and +3. So I can eliminate J and G because they have the opposite. And so I know it's either F or H. And if I'm not sure, this is where I actually plug it into my calculator to see, is the vertex down here at 1, -4? Or is the vertex at 1, -2? So I've gone ahead and graphed it in my Desmos, and this one's pretty easy when you see it in Desmos. Look, the vertex is right here at 1, -4. The x-intercepts are at 3 and -1, and that should help us to identify easily that F is the answer. It might look like H, but remember, look at that vertex, 1, -4. This vertex is at 1, -2. So make sure to look at the vertex to get that answer. Let's go ahead and look at the second one. Very similar, we can graph it in our calculator to see, first of all, we can tell that it opens, because it's negative in the front, the leading coefficient is negative, it should open down. So that should eliminate a few of our answer choices. Let's eliminate this one and this one, because they both have arrows opening up. So it's either A or D, and now I'm going to go to my calculator. This is another example where the vertex is really, really important, because please note the vertex is right up here at 3, 8. So let's look at the 2 graphs that we have. If we look a little closer, only one of them has a value at 3, 8. Let's see. This one is at 3, 8, the vertex, whereas this one looks more like it's at 3, 10. So it's very important to know which one is the correct answer just based on some of those key features like the vertex or the roots. So multiple choice really isn't too hard on the STAR test as long as you know how to use your calculator. And remember, you can use your calculator on any of these graphing questions. I personally really like the Inspire because you can pull up the table and get all of the points. Okay, so use whichever one you like. Have a great day, guys, and raise your hand if you have any questions for your teacher.